In the last lecture related to electrostatic, we have discussed about the potential due to a point charge, the value of which we have obtained as V equal to 1 by 4 pi epsilon naught Q by R. Now, this potential, it's a scalar quantity, it is a scalar quantity. Now, if there are a number of charges like this Q1, Q2, Q3, Q4, Q5, Q6, and we need to find out the potential at this point, then as this is a scalar quantity, so the potential from the superposition principle, from the principle of superposition, the total potential due to all the charges will be given by V is equal to V1 plus V2 plus V3 plus V4 plus V5, so and so on. So ultimately the summation, the summation will be a scalar summation. Now suppose we need to find out, before moving further, we just talk about the dipole. What is dipole? Further, the unit, the SI unit of potential, SI unit of potential is volt. Okay. So dipole, it is an arrangement. It is an arrangement where two charges of equal magnitude but opposite polarity separated by a very small distance constitute a dipole. Now we need to find out the potential due to a dipole. So the next topic is potential due to a dipole at any arbitrary point. So we'll just draw a dipole. Suppose this is the dipole, and we need to, the dipole is separated by a very small distance, let it be 2D, and we take any point making an angle theta with the axis of the dipole at a distance r. What we do is this, that we'll join these 2 points. Here we have minus q charge and here we have plus q. We drop a perpendicular from here over here. Let this point be P, this one is A and B. So and this point is O. So we drop a perpendicular from B on OP at N. So this is the midpoint and this angle is theta. So therefore this will be D cos theta. So ON is equal to D cos theta. Similarly, we extend this part. This is theta. So let it be AM, which is again a perpendicular. So OM will be equal to D cos theta. Here this is D and this is D, which makes this 2D. So we'll get the effective length PB will be equal to PN, which is equal to R minus D cos theta. Similarly, AP is equal to OP plus OM, that is R plus D cos theta. So the total potential at the point P will be given by V1 plus V2, where V1 is potential at P due to minus Q, and V2 is potential at P due to plus Q. So now putting the value of V1, let V1 will be equal to 1 by 4 pi epsilon naught, it's minus Q by the distance is AP plus 1 by 4 pi epsilon naught plus Q, and distance is PB. So ultimately we will get something like this: V equal to V equal to 1 by 4 pi epsilon naught minus by R plus D cos theta plus 1 by 4 pi epsilon naught Q by R minus D cos theta. We'll take out the term Q by 4 pi epsilon naught, which is common to both of this, and we'll get minus 1 by R plus D cos theta plus 1 by R minus D cos theta. So V will be equal to Q by 4 pi epsilon naught R square minus D square cos square theta, and we'll get minus R plus D cos theta plus R plus D cos theta. So ultimately we'll get 2QD cos theta by 4 pi epsilon naught R square minus D square cos theta cos square. So this is the V, and it is the general relation. And we have two cases related to this. Number one is when P is at the bisector of the dipole, then theta will be equal to 90 degree, therefore V will be equal to 0. So this P could be at any point, say like this, minus Q plus Q, so it could be anywhere over here. Another is when theta equal to 0 degree, so it means anywhere over here or here. Okay, in this particular case we'll have V is equal to 2QD by 4 pi epsilon naught R square minus D square. So these are the two different cases which will have these are two particular cases, and this one is a general case for the dipole actually. So this is where this is the one derivation rather related to potential, which is very important for the student of plus 2 preparing for learning this electrostat. So the next part will continue in the next lecture. Thank you.